Far, we explored how limits are basically asking what the value of a function would be as you approach and get closer to a certain point, whatever that point may be. So let's take a look at more limits. And now let's explore the idea of one-sided or one-hand limits. All right, so first off, we have the function showing fx equals e to the x. You can see our function here, drag out the point along it. We can see that as the function goes to positive infinity, we can see it just keeps growing. So we can assume that the limit of fx as x approaches infinity equals infinity. But we can drag along this point and see that as we go farther and further in the negative direction, approaching negative infinity, we're getting closer and closer to 0. Obviously, we're never going to reach a negative infinity, but we can assume and safely say that the limit as x approaches negative infinity of f of x equals 0. Now let's look at those one-hand limits I was talking about. Here we have g to the x. We can see the function here as we zoom out. We can assess the limit as the function goes to the point x equals 2. We can assess it graphically, but since we can see that the function is defined at 2, we can just plug it in and find out that the limit as x approaches 2 for g of x is just negative 2. Now, one thing I want you to notice about this limit is that there is no right side of this function. So we can only evaluate the limit as we're approaching 2 from the left. We don't have anywhere on the right to approach it from. Keep that in mind. Here we have h of x. Here we can see the full h of x picture. We can see here that we can take the right-hand limit of h of x as it approaches 0, and it happens to be 0. So the limit as x approaches 0 for h of x equals 0. Now once again, here we have nowhere on the left of x equals 0 to approach that point. So our limit as it stands now is just the limit as x approaches 0 from the positive direction from the right side is equal to 0. Up here, we can see the same thing happening. As we approach the point x equals 3 from the left, we can see that our function is approaching the point 13.5. Now, there's nowhere to approach this point from the right-hand side, so our limit is just going to be as the limit of h of x as x approaches 3 from the left-hand side is equal to 13.5. Finally, here we have this piecewise function. We can see that this piecewise function is broken into many different pieces and it's not all one connected line. We can evaluate that the limit of f of x as we approach 0 from the left-hand side is 2. But now you can tell that the same thing is not true when we approach x equals 0 from the right-hand side. When we approach x equals 0 from the right-hand side, the limit looks to be 0. We can see the same thing happen again when we approach the point x equals 2 from the left. As we approach the point x equals 2, we happen to get around the value of 1.1. But as we approach x equals 2 from the right, it looks that our limit is 4. So once again, the limit as we approach x equals 2 from the left and the right do not match. So be careful when you're taking tests, because for a limit to be valid, for a limit to be defined, the left side limit and the right side limit must match. You can't have one-sided limits, and you will be asked about one-sided limits. It's absolutely important that you get the notation right for these types of limits, because you could lose very easy points and it could affect your grade. If you want to make sure that you get that notation down as I just talked about, make sure to watch my next video. In that video, I will be covering all the notation tips, tricks, and how to make sure that you don't mess that up.